Hello everyone, this is Siddesh Shilke. I am pursuing post-graduation degree in Masters in Construction Engineering and Management from CEPT University. My roll number is PCM25468 and I will be presenting you the feasibility study in semester 1 which is all about construction project formulation and appraisal. Project brief. The project I did study was the Executive Leadership Guest House project located in Shantigram, Ahmedabad, and explains the core purpose behind its development. The project aims to eliminate the organization reliance on external hotels by creating a dedicated, premium quality accommodation facility exclusively for leadership teams, visiting executives, and strategic guests. By developing this in-house infrastructure, the organization gains greater control over hospitality standards, security, privacy, and service consistency. It improves convenience for visiting leaders while optimizing long-term operational expenses and associated with stays. So it establishes the project's strategic importance as it directly supports the organization's long-term vision of enhancing its campus facilities and strengthening executive experience. Overall, it sets the context from the remaining by highlighting the need, value, and intended outcomes of developing a well-planned, efficient, and a high-quality guest house that aligns with the organizational expectation and provides long-term functional and economic benefit. The project brief outlines the core fundamentals of the Executive Leadership Guest House. It is a 30-month greenfield hospitality project with a plot area of 12,500 square meter and an item rate contract approach. The building consists of G plus 18 floors, a three-level basement, and a total built-up area of more than 80,000 square meter. The project aims to deliver 570 rooms, support internal guest accommodation, reduce dependence on external hotels, and strengthen corporate brand experience. The brief also highlights its location at Shantigram with good accessibility to the airport and railway station. The scope covers civil works, interiors, landscape, MEPF, and O&M, and emphasizes sustainable and energy efficient design. Work breakdown structure. This presents the WBS, which organizes the entire project into structured, manageable components. It highlights the main stakeholders, the client, consultants, and contractor, and explains how their coordinated involvement ensures efficient planning and execution. The WBS clarifies the project scope, defines responsibilities, and establishes cost and schedule baselines, ensuring that every discipline understands its deliverables and timelines. It supports systematic procurement, enabling the onboarding of qualified consultants and contractors through transparent tendering processes. With this foundation, the project can be executed smoothly across all major work areas including civil construction, MEP installations, facade works, and interior finishing. The WBS essentially act as the backbone of project governance, enabling better communication, reducing ambiguity, and enhancing decision making. By breaking the project into smaller, actionable elements, it ensures that the progress can be monitored, execution process remains well coordinated and under control. This breaks the project into major phases: feasibility, procurement, design development, construction, and O&M. It outlines the key tasks under each phase, such as feasibility studies, tendering, contractor selection, mobilization, civil and finishing works. It also emphasizes systematic planning, interdisciplinary integration, and smooth execution as core project principles. So this slide explains the management process and the guide the project under the WBS framework. It emphasizes the importance of establishing clear accountability among all stakeholders to ensure that responsibilities are well defined and transparently communicated. Strong client involvement is highlighted as a key factor, ensuring the expectations are aligned and decisions are made efficiently. It also stresses the significance of multidisciplinary coordination because the project integrates inputs from the architecture, structural, engineering, MEP design, facade specialists, interior designers, and various contractors. By defining roles and processes early, the WBS manages overlap reduces delays, and enables smoother collaboration. This principle enhances the project's organizational flow, prevents communication gaps, and ensures that the handovers between different work stages are seamless. Ultimately, this structured coordination supports a smooth transition from planning to design, construction, and operational phases, ensuring the project progresses with clarity, transparency, and efficient teamwork. This expands the design development and O&M phase in detail. It shows the role of architectural, landscape, structural, MEP, facade, vertical transport, lighting, and hospitality consultants along with their deliverables. It also outlines the facility management and external agencies' responsibilities in operations. Key benefits include clear accountability, strong client involvement, and transparent coordination. Project baseline schedule. This outlines the comprehensive 30-month baseline schedule that guides the project from start to finish. It divides the timeline into major phases: feasibility, procurement, design development, and construction, ensuring each stage is well planned, logically sequenced, and connected to critical parts. The baseline schedule acts as a roadmap, helping teams track progress, identify dependencies, allocate resources, and predict potential delays. It allows management to anticipate challenges early and implement corrective actions before issues escalate. By mapping key activities and milestones, the schedule ensures workflow continuity and helps maintain momentum throughout the project lifecycle. It also supports effective coordination among multiple disciplines by aligning deliverables with clear timelines. The baseline schedule strengthens project control by offering a structured framework for monitoring, reporting, and decision making. Overall, it plays a vital role in ensuring the project stays on track, meets deadlines, progresses efficiently towards successful and timely completion. Choosing by advantage. This introduces the CBA method used for two design decisions: structural system, that is the precast versus steel, and facade system, that is the curtain wall versus GRC cladding. It highlights the roles of the client, designer, contractor, and facility operator in evaluating long-term advantages rather than only cost. The first design problem: structural system. This compares the precast and steel frame structure using factors like construction speed, fire rating, thermal performance, dimensional precision, vibration, and lifespan. While steel is cheaper and precast score higher in quality and performance, achieving a higher IOFA score. This also includes the precast provides better long-term value. Design problem 2: facade system. This summarizes the CBA evaluation and presents a clear decision. GRC provides significantly better overall value compared to the curtain wall system. With an index of advantage of 790 versus 680, GRC demonstrates stronger performance across key technical and operational parameters. It is also 39% more cost effective, reducing the facade expenses without compromising durability or aesthetic quality. It also highlights GRC benefits such as its longer lifespan, better acoustic insulation, improved thermal performance, shorter installation duration, all of which enhances project efficiency and long-term building performance. By combining lower cost with superior technical performance, GRC is positioned as the most advantageous facade option. The analysis reinforces how the CBA method supports data-driven design decisions that improve life cycle value, minimizes risk, and ensures the building achieves optimal performance standards. Bid process management. This explains the structure, procurement, and bidding strategy due to select consultants and contractors for the project. Through a SWOT analysis, it identifies the strengths of the procurement environment, such as an established vendor network and the availability of specialized contractors, as well as weakness like the potential for late design changes and the complexities of coordinating multiple work packages. It also discusses opportunities created by competitive markets and risk involving regulatory changes or interface disputes. By establishing a clear tendering sequence, the project ensures transparency, fairness, and the selection of the most capable teams. The process includes evaluating credentials, experiences, technical expertise, and financial competitiveness. This structured approach reduces uncertainties, improves decision making, and strengthens project governance. Ultimately, it demonstrates how effective bid process management supports smoother execution, minimizes cost overruns, enhances quality control, and ensures that only qualified professionals contribute to the project delivery. This details how the project evaluates bids using a combination of technical and financial assessment to ensure the selection of high quality consultants and contractors. It highlights essential contract conditions such as site access regulation, quality assurance system, safety protocols, and sustainability compliance. These conditions set clear expectations and define the rules under which work must be executed. By implementing strict quality and safety standards, the project ensures consistent performance, reduces the likelihood of delays, accidents, or disputes. It also emphasizes that proper contract coordination throughout the construction. It helps all stakeholders understand their responsibilities, deliverables, and reporting requirements. Through transparent procurement procedures and clearly defined contractual obligations, the project minimizes risk, enhances governance, and ensures that each phase progresses in a controlled, compliant, and efficient manner that aligns with organizational goals and regulatory frameworks. This finalizes, integrates the project major learnings and explains the selection methods such as QCBS, CQS, LCS. It highlights how the WBS helped clarify responsibilities, streamline communication, and strengthen coordination among teams. The baseline schedule ensured predictable planning, timely monitoring, and early identification of delays. The CBA method supported performance-based decisions, ensuring the structural and facade systems were selected based on measurable benefits rather than initial cost alone. Bid process management standard procurement by promoting fairness, transparency, and the selection of competent vendors. Together, this methodology ensured a more reliable, efficient, and a high-performing project delivery approach. The conclusion shows that the integrated structured planning, data-driven decision-making, and transparent procurement not only improves execution quality but also reduces risk and enhances long-term value. Overall, it reinforces that the project benefits significantly from disciplined management practices across all the phases. Thank you.